So the point P lies on C where T equals half. All right, cool. Find the equation of the tangent to C at the point P. Okay, so that's just a general idea. So first things first, we're talking about a typical straight line equation. So y equals mx plus c will do, where m is your gradient, which we have in the previous equation. Dy dx is the gradient equation. And we know the value of t here, so t is half, so we can say 2 over half squared is the gradient. So let's put a note there. So m equals 2 over half squared. And if you're not sure, you can literally just put that in a calculator. And in doing that, you should literally get... Now, this is the easy part. So now our final equation is now y equals 8x plus c. So now we just need to find the x and y coordinate to get c. And since we know the point P lies on c where t is half, we can plug in the value for half for t and then get our x and y coordinates. So let's do it. So we can say x equals 3 times half, so 3 over 2 minus 4. And y equals 5 minus 6 over half, so 12. In other words, 6 over half is just 12. Now putting this all in the calculator, I mean, it's not too difficult, but you know, this is a calculator, so better not to get wrong. The first one will give us negative 5 over 2, and then the y solution should give us, well, negative 7. That's it. Now plugging these into the gradient equation, so I'm just going to change color pen. What do we get? So we should get minus 7 equals 8 times negative 5 over 2 plus c. Hence, putting this in the calculator, so making c the subject, you're going to have minus 7 take away all of this term here. So minus 7 minus 8 times minus 5 over 2, you should get 13. And voila, guys, that means that the final solution is going to be now, the equation of tangent is going to be y equals 8x plus 13, where p is 8 and q is 13.